The nighttime sky, glittering with stars of various brightness and colors, form pictures that capture the imagination. Astronomers have long wondered why the stars are so diverse, since they are born out of the same material that lies between the stars, vast clouds of hydrogen and dust. Gleaming brightly in the winter sky is the constellation Orion, the Hunter. Located only 1,500 light-years away in Orion's sword, below the belt, is the Orion Nebula. This immense gas cloud and intricate filaments formed by the interstellar medium is the brightest, youngest star-forming region close to Earth. This target was so appealing to astronomers that they used all of the instruments on the Hubble Space Telescope to take snapshots of the nebula. The parallel images of the Advanced Camera for Surveys, Wide Field Planetary Camera 2, and NICMAS provide a detailed mosaic to study.
That's your brain, folks.
The star formation history of the Orion Nebula.
We see the entire history of star formation printed into the feature of the nebula. We see arcs, rings, blobs, pillars, and each one tells us something about the encounter of different winds, about the ejection of material from stars in different evolutionary ages.
The four brilliant stars at the Orion.
The Pineal Gland, the ancient Mayan myth of the hearthstones. They say that that's where the flame of fire bursts forth. And the turtle, that's the hearthstones, the trapezium.
Nebula's center are called the trapezium. When the gas in Orion's interstellar cloud collapsed under its weight, oatmeal clumps of hydrogen and dust were formed. The density and pressure within the center clumps caused a nuclear fusion and bore a trapezium star. An intense illumination ignited, releasing energy and stellar winds. This energy pushed open the interstellar cloud and formed a bowl-like cavity. When winds collide with other material radiating from the cloud, a bow shock is formed. The nebula's right side forms a rippling, curled edge from the impact of shocks on the dust and gas. The outflow from smaller stars near the rippled edge cut through the stationary gas and formed beautiful, elongated jets. A thin veil of dust and gas overlaps the shallow bowl shape. Hubble's resolution reveals thousands of stars surrounding the highly illuminated area of the four trapezium stars. For the first time, an entire star formation history is presented to us in a rich treasury.
In the case of the Orion Nebula, really the background is what kills ground-based observation. You need superb resolution to keep your stars like little tiny dots. If they are rings, disks, larger and larger depending on the atmosphere, on the blurring, then the background that you get is also so high that you lose sensitivity. I know that we got from Hubble basically 100 times fainter sources that were previously observed at this wavelength from the ground. So it's a big step. It's 5-6 magnitudes is a big change, and actually opens new science. We see new, for the first time, brown dwarfs in the visible that were impossible to see from the ground.
Laid out on a plate for astronomers to catalog are over 3,000 stars of various ages, sizes, masses, and types. Red stars, blue stars, arcs, jets, protoplanetary disks, binaries, and now brown dwarfs. Seeing these fainter objects with the Hubble's Advanced Camera for Surveys, astronomers are able to study clearly disks and brown dwarfs. Brown dwarfs are so-called failed stars, objects that are too small to be ordinary stars because they cannot sustain nuclear fusion in their cores to glow. One of the most interesting findings is brown dwarf binaries, where two brown dwarfs orbit each other. This study will help solve the link between star and planet formation. Hubble revealed with its resolution in the visible light a rich tapestry of faint objects in the star factory of Orion's nebula. Hidden from view under the dense veil of dust and gas are the images of early star birth. To see stars as they first illuminated the universe, a telescope is needed with Hubble's resolution and the capability of detecting infrared light to pierce the dense veil. NASA is developing a telescope that will be able to fill these requirements, called the James Webb Space Telescope, or JWST. Astronomers worldwide anxiously await JWST to peer into the stellar nursery and see the first light of a star's birth.
In 2012, November 1st, 2012, an international team of astrophysicists says the famous Orion Nebula has a black hole at its heart, whose mass is some 200 times the mass of the Sun. One of the most recognized constellations is Orion, with its 3 prominent belt stars, or 3 stars in a short, straight row on the sky's dome. This constellation can be seen at night at this time of year, ascending in the east, visible from all parts of the globe. Last week, November 1st, 2012, an international team of astrophysicists announced the results of their work in computer modeling, which suggests that a famous nebula or cloud in the Orion, known as the Orion Nebula, has a black hole at its heart, whose mass is of 200 times that of the mass of our Sun. If it exists, a black hole would reside somewhere between the 4 bright stars which mark the center of the Orion Nebula. These stars are known as the trapezium. The trapezium stars are 4 brightest stars in the open star cluster known as the Orion Nebula cluster, consisting of young stars newly born only 1 or 2 million years ago from the Orion's nebula gas and dust clouds. The Orion Nebula cluster has long been known as peculiar. Its stars move at a rapid speed, as if the whole cluster were flying apart. If the cluster contained more high-mass stars, the speed of these stars would be easier to understand, but it doesn't. And so astronomers have wondered why these stars move so rapidly. An international team of astrophysicists, led by set up a computer model of the Orion Nebula cluster. The model required a new method of dealing with the gas in this region of space, and the way it is driven out from the young star cluster by the intensely radiating high-mass stars of the trapezium. The model showed that as the gas was being driven outward, the cluster began to expand. That explained why most stars in the Orion Nebula cluster move so rapidly. Many of the heavy stars were slingshot out of the cluster, while some were driven into the center of the cluster and collided with the most massive star there. At some point, this massive star became unstable and imploded into a black hole, with a mass about 200 times larger than the Sun. I also wanted to make the correlation in this video how 9 is the key. 9 is the key to everything. 9 is, I believe, the Fibonacci sequence. Watch. You start here. Right there. And if you look at the Orion Nebula from afar, not on this view, but a side view on a Hubble image, you can overlay the painting by Michelangelo. We've gone over this. You know, the creation of Adam painting in the Vatican. It overlays, all data points match up perfectly, and you can overlay the brain on top of that as well. And I don't know if this is by divine design or what, but look at it, I'm on the trapezium. It's black, I'm in a black hole, and they say there's 4 stars in there, right? Why is there 5? Why does it have 2 0-1s? Oh, and by the way, 0-1, 0-1, 0-1, 0-1, 0-1, 0-1, 0-1. What is that? That's the algorithm of computers, right? Okay. Also, I just shut the time down so it would stay still. Also, not only do we have the 010101, we have the cross with the circle in the middle. Huh? Tell me that's divine. I mean, it answers all the questions for me. If you're not ready for the info, you're not ready for the info. But there it is, folks. It goes way deeper than that. There's so many more correlations. I mean, so many more things that line up the pyramid in Giza, everything. So take it for what you will. Love, peace, and grace. I love you all.